Section 5, question 14. The value V in millions of pounds of a cruise ship 2 years after launch is given by the formula V equals 252 e to the minus 0.06335t. Part A says, what was the value when launched? Well, remember, one of the categories for these questions is to find an unknown power, and that's to take natural logs of both sides. I'm not looking for a time, though, in part A. I'm looking for a value. So the value is given down here. That's not an unknown power, so that's just a straightforward substitution question. Now, what's true when the thing's launched? What I can definitely say is true at that point is that t is equal to 0. So the value would be given by 252 e to the minus 0.06335 times 0. Now that means that full power would collapse down to 0, so it's 252 e to the 0. Anything to the power 0 is equal to 1. Therefore it's 252 times 1. So it's in millions of pounds, remember, and the final answer would be 252 million pounds. 252 million pounds for the value of the ship when it's launched. Part B says the owners decide to sell the ship once its value falls below 20 million pounds. After how many years will it be sold? So this time I'm looking for a time. The time is up in the power line. So that means that this is a natural logs question. So we're now going to take the value to be 20 million. So it's 20 equals 252 e to the minus 0.06335 t. So that'll give me e to the minus 0.06335 t is equal to, I'm going to bring the 252 down, divide, so that'll be 20 divided by 252. So that's e to the minus 0.06335 t is equal to, well, it's two decimal places, that's 0.08. I'm kind of flush here, there's nothing in front of e, so I'm ready to take natural logs of both sides. So I would communicate that to the examiner. I'll leave that bit out just now. So log to the base e of e to the minus 0.06335 t is equal to log to the base e of 0.08. I'm then going to use law 3 and bring that down, so it's going to be minus 0.0 so that'll be minus 0.06335 t log to the base ev is equal to log to the base e of 0.08. Remember again that log to the base ev is 1, so that collapses down to minus 0.06335 t is equal to log to the base e of 0.08. T then will be log to the base e of 0.08 divided by minus 0.06335 and enter that into the calculator. Into one decimal place, that will be 39.9 years. That's the final answer. Section 5, question 15. Variables x and y are related by the equation y equals kx to the n. The graph of log to the base 2 of y against log to the base 2 of x is a straight line through the point 0.05 and 47. Find the values of k and n. The first thing I'm going to do is get an easy mark by picking up the gradient. So y2 minus y1 over x2 minus x1. That's 7 take away 5 over 4 take away 0. That's 2 over 4, and that's 1/2. I'm now going to take log to the base 2 of both sides. So log to the base 2 of y equals log to the base 2 of kx to the n. I'm going to use law 1 and split it up. So log to the base 2 of y equals log to the base 2 of k plus log to the base 2 of x to the n. I'm now going to use law 3 and bring that down. So log to the base 2 of y is equal to n log to the base 2 of x plus log to the base 2 of k. Now I can see that the gradient is represented by n. I've already got that, so the gradient was 1/2, so n is equal to 1/2. The y-intercept, as I can see, is equal to 5, and the y-intercept is given by log to the base 2 of k, as we can see. So log to the base 2 of k is equal to 5. Then use my loop. 2 to the power 5 is equal to k. Take your time with that. 2 to the power 5 is equal to 32, and that's the end of the question.